So we start with the car giant Tesla. It's raised its spending plans to more than $25 billion. Something happened on the stage in Texas last week that the rest of the auto industry is still trying to figure out how to respond to. Elon Musk walked out, lifted a small piece of hardware over his head, and within 48 hours, executives at 3 major car companies reportedly called emergency meetings. One engineer who saw the footage said he felt physically sick. Another said it was over. Not the kind of over you say casually, the kind you whisper. So, what is this thing? Why is it terrifying every rival in the electric vehicle race? And could it really end the war overnight? As the boss Elon Musk plans to invest more in artificial intelligence, robotics, and chips before the breakthrough. For more than a decade, the world's biggest car companies have been locked in a fight that many believed would decide the future of transportation forever. The arrival of electric vehicles did not just introduce a new type of car, it changed the direction of the entire global auto industry, and one company appeared to be leading that future: Tesla. But here is the part most people forget. In the beginning, almost no one thought Tesla would stay on top for long. The company looked ambitious, innovative, and exciting, but also fragile. Compared to massive automotive giants like Ford Motor Company, General Motors, Toyota, Motor Corporation, and Volkswagen Group, Tesla seemed small and inexperienced. These traditional companies had spent generations building enormous factories, mastering precision engineering, and creating worldwide production networks. Many experts believed it was only a matter of time before these powerful corporations caught up and pushed Tesla aside. Tesla's Cybertruck is the auto industry's biggest flop in decades. And honestly, for a while it looked like they would. The competition did improve. Electric cars from other brands became more stylish, more reliable, and more practical for everyday life. Battery performance climbed faster than many predicted. Some analysts even began predicting that Tesla's advantage would eventually vanish completely. Then, something unexpected happened. Tesla introduced a breakthrough that completely changed the atmosphere inside the automotive industry. It was not another car design. It was not a stronger battery. It was not upgraded software. It was a motor. But this was no ordinary motor. Engineers who studied the technology reportedly reached a disturbing conclusion almost immediately. Tesla was no longer just leading the competition. The company had stepped onto a level far beyond what most rivals could currently reach. And here's the catch. The most frightening part for competitors was not only how powerful and efficient the motor appeared to be, it was how difficult it would be to copy. Experts quietly admitted that recreating such technology could take many years, possibly close to a decade. And by the time other companies finally got there, Tesla would already be somewhere else. Before we go any further, do me a quick favor. If you enjoy these deep dive breakdowns on the technology shaping our future, tap that subscribe button and turn on notifications so you never miss the next one. It really helps the channel, and it makes sure stories like this one keep landing in your feed. So why now? Why did Tesla, of all moments, choose this exact one to unveil something this disruptive? The answer is uncomfortable, and it starts with a truck nobody seems to be buying. The pressure inside Tesla. Ultra-hard, cold, rolled, stainless steel alloy that we've developed. We're going to be using the same alloy in the Starship rocket and in the Cybertruck. Here's the part most people miss. Tesla needed this breakthrough, and it needed it now. The Cybertruck, which was once promoted as the future of transportation, had quietly become a problem. Despite years of hype and worldwide attention, sales reportedly fell far below what Tesla expected. And recent reports suggest the situation became so difficult that nearly 1 out of every 5 Cybertrucks registered during one quarter went to companies connected to Musk himself, including SpaceX and xAI. Internal registrations were propping up the numbers. Recalls were chipping away at confidence. And in a market where buyers suddenly had a dozen electric options, Tesla's loudest product was not pulling its weight. Musk needed something that could not be questioned, something the entire industry would have to react to. and inside a quiet engineering bay far from the noise of the Cybertruck headlines that something was already taking shape, breaking the rules. To understand why this motor sent shockwaves through the automotive industry, you first need to understand one harsh truth about electric vehicle engineering. The laws of physics are extremely difficult to beat. And for a long time, the industry just accepted that. For many years, car manufacturers around the world believed they were trapped by a painful compromise. An electric car could be incredibly fast and powerful, or it could be efficient and travel long distances on a single charge. Achieving both at the same time seemed almost impossible. Engineers would sit in meetings and shrug. That was just how electric motors worked. Whenever engineers built high-performance electric cars, those cars became heavy, overheated, quickly wasted energy, and required massive cooling systems just to survive. On the other hand, vehicles designed for efficiency usually felt less exciting and lacked the thrilling acceleration drivers wanted. This trade-off was accepted across the industry as an unavoidable reality. Most companies believed physics had already set the limits. They stopped trying to push past it, but Tesla refused to accept those limits. Instead of working within the traditional approach, Tesla's engineers searched for a completely different solution. After years of research and experimentation, they developed one of the most advanced electric motor designs ever placed inside a consumer vehicle. At the center of this breakthrough was something that in theory was surprisingly simple, but incredibly difficult to perfect: a carbon fiber-wrapped rotor. Think about that for a second. Inside every electric motor is a spinning component called the rotor. During operation, this rotor spins at unbelievably high speeds. As the speed increases, the forces inside the motor become extreme. The faster it spins, the more the motor feels like it is trying to tear itself apart from the inside. Most traditional motors physically cannot survive that pressure. They fly apart, they warp, they cook themselves into junk. Tesla found a way around it by wrapping the rotor in carbon fiber, a material famous for being both incredibly strong and extremely lightweight. This wrapping acted like protective armor, holding the rotor together even under enormous stress. The result was astonishing. Tesla created a motor capable of spinning at more than 20,000 revolutions per minute, a level rarely seen in ordinary passenger vehicles. Speeds like that were usually associated with specialized industrial machines, not luxury sedans meant for every day. Driving. 20,000 revolutions per minute in a car you can drive your kids to school in. Let that sit for a moment. But raw speed alone was not the real breakthrough. What truly made Tesla's design revolutionary was the control and stability it achieved at those extreme speeds. The carbon fiber wrapping reduced vibration and kept the rotor steady and balanced. That stability improved the motor's magnetic performance, allowing more electrical energy to become actual motion instead of being wasted as heat. And honestly, that is the part that quietly destroys competitors. In a normal electric motor, a significant portion of the energy you pull out of the battery is wasted on heat noise and vibration. Tesla figured out how to claw most of it back. More of the battery actually moves the car, less of it gets thrown away. Same battery, more range, more speed, less heat. It is the kind of efficiency win that does not just sit in one product. It compounds across every car Tesla builds from now on. The benefits completely transformed expectations for electric vehicles. The motor delivered massive, instant torque, breathtaking acceleration. It remained highly efficient during long-distance driving. It stayed compact and lightweight while requiring less cooling than many competing systems. And get this, that last part matters more than people realize. Cooling systems are heavy, expensive, and they steal space that could be used for batteries, passengers, or cargo. A motor that runs cooler means less complexity, less weight, and more usable range from the same battery pack. Every other automaker has to add cooling pumps, radiators, coolant lines, and control electronics just to keep their motors alive during hard driving. Tesla quietly removed a large portion of that headache. The world saw the full power of this technology in the Tesla Model S Plaid. Picture the demonstration, a test track, a handful of automotive journalists standing behind a barrier, phones up, expecting fast. Musk somewhere off to the side, hands in his pockets. The Plaid launches. Less than 2 seconds later, it is at 60 miles per hour, and you can watch on the footage as their faces shift. One reporter actually steps back. Another laughs at the kind of laugh people laugh when their brain is not caught up yet. That car outperformed many exotic hypercars, worth millions of dollars. And the most unbelievable part was this. The Plaid was still a comfortable luxury sedan, capable of carrying passengers for hundreds of miles on a single charge. Engineers from competing brands reportedly bought Plaids, tore them apart in private labs, and walked away frustrated. The motor was not just better, it was built in a way that made copying it extremely risky. Carbon fiber wrapping at production scale is a manufacturing nightmare. One small flaw in the wrapping process and the entire rotor becomes useless. Tesla had to solve that production problem before anyone else even tried, and they did it quietly, while everyone else was still arguing about battery chemistry. For decades, the auto industry claimed drivers had to choose between speed and efficiency. Tesla proved they could have both and built it cheaper, lighter, and easier to mass produce. And that is where things stop being about one motor and start being about something far more terrifying for everyone else in the industry. Because the people inside Tesla's Fremont factory already know what comes next. They have been building toward it for 4 years. Why rivals cannot keep up. Many companies in the automotive industry know how to create exciting prototypes that capture attention. They unveil futuristic designs, attract investors, and dominate headlines for a short time. But here's the catch. Building a few impressive cars is very different from producing millions of them successfully. That is where most companies fail, and that is exactly where Tesla has become one of the most feared names in the industry. Honestly, the automotive world is filled with the wreckage of companies that once promised to change transportation forever. They created beautiful concept cars and generated massive excitement only to run into serious trouble when production began. Making one advanced electric vehicle is hard. Producing millions of them consistently at affordable prices while still making profit is an entirely different challenge. Tesla understood this earlier than its competitors. While other companies focused mainly on flashy designs and marketing, Tesla spent years battling manufacturing problems behind the scenes. Production lines that did not work, robots that fought each other, bottlenecks that nearly killed the company more than once. Those difficult years are now paying off in ways the industry can no longer ignore. Recently, Tesla revealed that its next generation and drive units, the same family of drive units built around that carbon fiber wrapped motor, are being designed not just for speed efficiency or performance, but for something even more important: manufacturability. That single idea could completely reshape the future of electric vehicles. And get this, Tesla wants the entire drive unit motor electronics gearbox to cost only around $1,000 to produce. $1,000. Some competitors spend 3 to 5 times that amount just to achieve similar performance levels. The difference is not minor, it is massive. Sit with that number for a second. If a rival automaker is spending $3,000 to $5,000 on every drive unit they ship, and Tesla is spending $1,000, that gap multiplies across every single car they build, across hundreds of thousands of vehicles a year. That is the kind of margin advantage that quietly funds entire new product lines while competitors are still trying to break even. What makes Tesla even more dangerous is that the company keeps finding new ways to reduce costs while improving performance. Tesla is working to remove rare earth materials from its motors, reducing dependence on expensive supply chains heavily connected to China. At the same time, Tesla is redesigning its electronics to reduce the use of costly silicon carbide materials without sacrificing efficiency. And honestly, removing rare earth materials is not a small move. Those materials have been a choke point for the entire electric vehicle industry for years. If Tesla actually pulls it off, half the supply chain leverage that every competitor depends on quietly stops mattering. Think about that for a second. Each improvement strengthens the next. Lower production costs allow Tesla to lower vehicle prices. Lower prices attract more buyers. More buyers increase production volume. Higher production volume gives Tesla more manufacturing experience and efficiency. That experience then helps reduce costs even further. The cycle keeps growing stronger and faster. Every rival is racing to catch up to a target that is actively moving away from them. Meanwhile, the competition is bleeding. Ford Motor Company introduced impressive electric vehicles like the Ford Mustang Mach-E and the Ford F-150 Lightning. Yet the company reportedly lost huge amounts of money on its EV division. Now think about that for a second. Ford has been in the car business for over a century. They know how to build trucks. They know how to build at scale. And they are still losing money on every electric vehicle they ship. Lucid Motors developed luxury electric cars with advanced technology, but continued burning through cash at an alarming rate. Rivian Automotive attracted enormous attention and investment, yet production costs remain painfully high. Even major industry giants like General Motors and Volkswagen Group faced delays, software problems, and growing concerns about profitability. Honestly, this is what catching up to Tesla actually looks like from the inside. It is not glamorous. It is not winning. It is just losing money slightly slower than the company beside you. Among global competitors, only BYD company appears capable of challenging Tesla on a massive scale, especially in lower-cost markets. But here's the part most people miss. BYD's strength mainly comes from affordability, while Tesla is pursuing something far bigger. Tesla is not simply trying to build cheap electric cars. It is trying to build the most advanced and desirable electric vehicles in the world, while also making them affordable to produce. That combination is what makes Tesla so powerful, and why many customers increasingly believe the company is setting the standard for the future of transportation. And honestly, this is where the story takes a strange turn, because most people still think Tesla is a car company. That assumption might be the most expensive mistake the entire auto industry has ever made. The hidden empire. Tesla's true strength lies in combining multiple industries into a single, self-reinforcing ecosystem. And the new motor sits right at the center of it. Start with data. Every Tesla vehicle on the road is constantly gathering driving information. Every mile driven teaches Tesla more about road conditions, driver behavior, weather patterns, traffic situations, and unusual events. This matters because autonomous driving systems improve through experience. Tesla has accumulated more real-world driving data than almost any competitor on the planet. Think about that for a second. That advantage compounds over time. More vehicles create more data. More data improves AI systems. Better AI attracts more customers. More customers generate even more data. Competitors cannot simply buy this advantage overnight. They would need years of vehicles on the road just to catch up. And those vehicles would need to be desirable enough for people to actually buy them. Which brings us right back to the motor. A cheaper, more efficient, harder-to-copy drive unit means more Teslas on more roads, generating more data faster than anyone else can match. Then there is the battery business. Tesla invested billions into battery production because batteries are the most expensive component in electric vehicles. The company's 4680 battery cells aim to improve energy density, reduce costs, simplify manufacturing, and enhance performance. Most competitors still depend heavily on outside suppliers, which means they are paying somebody else's markup on the single most expensive part of every car they sell. Tesla increasingly controls its own future. That difference shows up in the price tag, and it shows up in the profit margin. And get this, the company also designs its own software computer chips, power electronics, and vehicle systems. When global semiconductor shortages disrupted the auto industry, Tesla adapted faster than many competitors by rewriting software for alternative chips. That flexibility exposed an important truth. Tesla behaves more like a technology company than a traditional automaker. Its manufacturing expansion tells the same story. Factories in Fremont, Shanghai, Berlin, and Austin form a rapidly expanding global industrial network. Future facilities planned in Mexico and potentially India could push production costs even lower while opening massive new markets. And every one of those factories is being tooled to build that $1,000 drive unit at scale. Then comes one of Tesla's most underestimated weapons, the supercharger network. For years, critics viewed Tesla's charging stations as a convenience feature. They were wrong. Tesla superchargers became one of the company's strongest competitive advantages because they are fast, reliable, widespread, and easy to use. Honestly, other charging networks often suffer from broken equipment, confusing payment systems, compatibility issues, and poor reliability. Drivers using rival networks have shared stories of arriving at stations that simply do not work, payment apps that fail to load, and waiting times that destroy any sense of convenience. Some drivers have pulled into stations only to find every plug occupied, every screen frozen, or every connector incompatible with their vehicle. Eventually, competing automakers effectively surrendered. Companies like Ford and General Motors adopted Tesla's charging standard so their customers could access Tesla's infrastructure. Think about how extraordinary that is. Tesla's competitors now rely on Tesla's own infrastructure to improve their own customer experience. Tesla profits when rival vehicles use Tesla chargers. That is not ordinary competition, that is ecosystem dominance. And here is the part most people miss. Every time a rival driver plugs into a Tesla supercharger, Tesla learns something. Charging patterns, peak usage times, regional demand, hardware performance under real load. Even when Tesla loses a vehicle sale to a competitor, it can still win on the infrastructure layer. The motor sells more Teslas. The Teslas feed the network feeds the data feeds the AI. And somewhere in a server room most people have never heard of, the data is doing something else entirely, something that scares competitors more than any motor ever could. Where this is all heading, the more closely people look at Tesla, the harder it becomes to describe it as just a car company. On the surface, it builds electric vehicles, but underneath it is developing into something much bigger. A technology company built around energy software data and artificial intelligence. A clear example of this shift is Tesla's Dojo supercomputer. Dojo was created specifically to train artificial intelligence systems using massive amounts of driving video collected from Tesla vehicles around the world. Instead of relying only on general-purpose computing systems, Dojo is designed to process this data faster and more efficiently. And here is the part most people miss. Modern AI systems improve by learning from huge amounts of real-world information. The more cars Tesla puts on the road, the more its AI gets to learn. The new motor makes more cars possible. Dojo turns those cars into intelligence. Most companies in the industry depend on external computing power, often renting it from major providers like NVIDIA-powered cloud systems, or services from companies such as Amazon, Google, and Microsoft. Tesla chose a different path. It is building much of its own computing infrastructure. The reason is simple. Tesla believes the future of its success will depend less on the cars it sells today and more on the intelligence of the systems those cars can run tomorrow. Think about that for a second. Every other automaker that wants to compete in AI-driven driving has to rent the compute, rent the data, and somehow build the cars too. Tesla is doing all three under one roof. When you control the cars, you control the data. When you control the data, you control the AI. When you control the AI, you control what driving will look like 10 years from now. That is not a head start. That is a different game. Honestly, this creates a self-reinforcing cycle that is almost unfair. Better motor technology lowers cost and improves performance. Lower cost and better performance attracts more buyers. More cars on the road generate more driving data. More data helps the AI systems learn faster. Smarter AI improves self-driving capability. Better autonomy increases the value of every Tesla on the road. Higher value allows higher profits. Those profits are then reinvested into more research and better hardware, which makes the next motor even more dangerous. The cycle feeds itself and keeps growing stronger over time. Now think about that for a second. Many observers argue that competition in electric vehicles is no longer just about building cars. Tesla is competing across many layers at once. Battery technology, software integration, manufacturing systems, artificial intelligence, real-world driving data, charging networks, global production scaling. For rivals catching up in even one of these areas would take years. Competing across all of them at the same time is something almost no company on Earth is currently equipped to do. And every one of those layers traces back to the same place, the motor, the piece of hardware muscled onto the stage. It is not a single product. It is the doorway every other Tesla Advantage walks through. A cheaper motor means cheaper cars. Cheaper cars mean more buyers. More buyers mean more data. More data means smarter AI. Smarter AI means a future Tesla owns and competitors have to rent. Think about that for a second. Every executive at Ford, General Motors, Volkswagen Group, Toyota Motor Corporation, Lucid Motors, and Rivian Automotive watched that reveal. They saw the same piece of hardware you saw. And the ones who actually understood what they were looking at probably did not sleep that night because they realized they were not behind on one product. They were behind on the foundation that every future product would be built on top of. There is no quick fix for that. You cannot buy your way out of it. You cannot patent your way around it. You can only try to build something equivalent. And Tesla already has a decade of head start. So the electric vehicle revolution is real, but it may not look like what many originally expected. Instead of a balanced market with many equal players, what may be forming is a world shaped by one company moving faster, learning quicker, and building a deeply connected system that others are still trying to understand. The new motor was not the announcement. It was the signal. So what do you think? Is this new engine really the moment the electric vehicle war ends? Or is the competition far from finished? Could another company actually catch Tesla in the next 10 years? Or has the gap simply become too wide to close? Drop your honest take in the comments. I read them, and the best debates always come from this community. Whether you think Tesla has already won this race or still has serious threats, waiting in the next few years, I want to hear it. If you made it this far, hit that like button so more people get to see this breakdown, and subscribe if you haven't already. There is a lot more coming on the companies and technologies that are quietly reshaping the world, and you do not want to miss what is next.